Hello there, Mr. Sutton here, bringing you the MCAS 2024 solutions. This is part 2 of a two-part series. This one is dealing with questions number 22 through 42, which are on the calculator section of the Massachusetts MCAS. For number 22, we have a polygon being translated left 3 units and up 4 units on the coordinate plane, and we just want to figure out how that's going to be written in terms of x and y values with these rules. So for going left 3, we're basically subtracting 3 from the x values, so I'll write that as x minus 3. For going up 4, we're adding 4 to the y values, so y plus 4. Now I just need to figure out whichever one of these has those two things in it. X minus 3, y plus 4, it looks like choice A. For number 23, we've got a semicircle with a diameter of 30 centimeters. And we want to know what's the closest to the area of this semicircle. So I'm going to start with an area formula. Now the area of a whole circle would be area equals pi r squared. This is a semicircle, so we just need 1/2 of whatever pi r squared comes out to. Now for the radius on this, we have to be a little bit careful. Radius is halfway across a circle. They give us the diameter here, the whole way across. So the radius is going to be half of this, or 15 centimeters. So I'm going to write 1/2 times pi times 15 squared. And now I'm going to go do that on the calculator. So here I am on the calculator. To put this in here, there's a few ways you could do it. There is a way on this one to actually get 1/2 and pi exactly. But if you don't have that fancy of a calculator, you can always just use 0.5 instead of 1/2. And instead of pi, we could use roughly 3.14. That should give us enough accuracy on this. And then we've got 15, and let me square that. Press enter. And that comes out to roughly 353 and some change. So 353 centimeters squared, that's going to be choice A. For this next problem, we have the current population of an endangered bird species at 1,800 birds, and we're told this population is decreasing at a rate of 5% per year. They just want us to create a function that can be used to model B of t, population of birds, t years from now. Now, since we're decreasing a certain percentage per year, this is an exponential function, which means we're going to want to use something to the effect of a times b to the t when we're writing out this function, something in this format, where a is your initial value when you start keeping count at like year 0, and b is what I have to multiply by each year in order to get the next year's population. So for the a value here, that's going to be the 1,800. And then for the b value, what we have to multiply by, well, if I'm losing 5% per year, that means I would start normally with 100%, but I'd have to take 5 away from that. So if I want to write 100% minus 5%, percent really just means divided by 100, right? So this is really just having like 1 minus 0.05, which means that to lose 5% every year, I have to multiply by 0.95 each year. Plugging all that in, we just end up with b of t equals 1,800 times 0.95 to the t power. The t remains the same. And this is our exponential function. For number 25, they're giving us the expression where we have the y root of 5. So we want to know what's equivalent to that. And the key to this one is just knowing kind of how to convert between fractional exponents and radical expressions. So we have that formula where we have the rth root of x to the p is really just x to the p over r. So in this case, we have an invisible exponent of 1 on the 5. So we can rewrite this as 5 to the 1 divided by y. And that is going to be choice B. For 26, they're telling us that we have a quadrilateral JKLM that was graphed on a coordinate plane. They didn't show it, but here are the coordinates of said quadrilateral. And then we're going to say that they're going to dilate this by a scale factor of 1/2 with respect to the origin. So on this graph, they want us to draw the new quadrilateral after that dilation. So let me start with a table of my old points, 2, 2, 6, 2, 8, 8, and 4, 8. And I'm going to make a new table with the new points, and then I'm going to graph those points. Otherwise, I have to draw the original and then do it visually. I prefer the table method, but I guess you could do it either way. So I'm going to do 1/2 times x and 1/2 times y. That's what a scale factor does, is you're multiplying whatever that factor is by the x and the y values. So let me do my x's first. We've got 1/2 of 2, which is 1, 1/2 of 6, 1/2 of 8 is 4, and 1/2 of 4 is 2. Now for the y values, 1/2 of 2 is still 1, that hasn't changed. 1/2 of 2 is still 1. Then we've got 8 goes to 4, and another 8 going to 4 again. So graphing each of these out, we have 1, 1, which is right here. 3, 1 is here. 4, 4 is all the way up here. And then 2, 4 is right here. And then just connect the dots. For number 27, this is going to be a multi-step problem involving this circle. So important things to keep in mind is that EG and FH are diameters. They're telling us that. And they're also telling us that EF and GH are parallel, which might also be important depending on what types of angles we want to find. So first thing they want, they're telling us here that the measure of angle EIH, that's this angle in here, is 42. I'm going to write that in right away just so I can have it in there. And now they want the measure in degrees of this arc FG. So one way you could get this is if you knew this angle here, it would match up with FG. This angle is actually a vertical angle with 42. So this angle, FIG, angle Fig, is also 42. And since central angles and their intercepted arcs are the same angle, this is also 42 out here for arc FG. So just to write it officially, measure of arc FG equals 42 degrees. For part B, they want to know the measure of arc EF over here. And one way we could do this, there's a few ways you could go about this. One way would be to figure out the measure of central angle EIF, and then that would match up with that angle. Another way you could do this is to realize that EFG, which is a semicircle, because EG is a diameter, this is a semicircle, we know that EFG arc has to have a measure of 180 degrees. And that means that EF is just going to be that whole 180 minus the 42 that we found on the last part of the problem. So that comes out to 138 degrees. And I'll just write that up here so I can have it for future reference. It might be helpful on future parts of this problem. For part C, now they want the measure of major arc FGE, this whole piece here. Now you might be thinking, okay, I've got 42 here, I've got 42 here. If I could only figure out this other missing arc, I could add those three together and that would give me what I need. And that's definitely one way to do it. Another way you could do this is to realize that FGE is everything except for that 138 degree arc you found in part B. So if you just take the whole 360 of the circle and subtract this 138, that would also give you the arc that we're looking for here. And that comes out to, I think, 222? Yep, 222 degrees. This is the calculator section though, so absolutely feel free to double check that on a calculator to make sure you got the right answer. For the final part of this question, they want the measure of angle FHG. So FHG, it's this little angle in here. We need to figure that out. Many ways to do this. Probably the most straightforward based on the information we already have. Since this is an inscribed angle, we know that the arc that it intercepts over here is going to be twice whatever this angle is. Another way of saying it is that this angle is going to be half of the intercepted arc over here. Again, that's a property of inscribed angles. So that means that we really just want half of the 42 we found in part A, and half of that gives us 21 degrees for that angle. For 28, An executive at a company expects sales of a new product to increase by 20% per year. That's optimistic. And we know that they were $110,000 at the end of the first year. So based on this, what are the expected sales at the end of year 3? So to increase by 20% each year, we have to take the original amount, which was $110,000, and we have to multiply that by 1.2. That's 100% plus 20% is 120%, so we're multiplying by 1.2 each year. Since we want the sales at the end of the third year, that means we have to do this twice. So we have to do 1.2 times 1.2, or simply 1.2 squared. Let's go to the calculator for that. So here I am on the calculator. I've entered all that stuff in off camera, and if I press enter, that comes out to $158,400, which matches exactly with choice B. On this one, we have a right circular cylinder with the dimensions shown in this diagram, and we want the volume, as close as possible anyway, to the cylinder here. So volume formula for a cylinder, this is one of your formulas on your reference sheet that you can look up. It's going to be V equals pi r squared times h, which if you forgot the formula, I mean, it's basically just taking the area of the circular end here, the circular base, and multiplying it by the height. In any case, we need to figure out what we're plugging in for these things. R is going to be the trickiest part of this because we want half of this 2.75 diameter that they're giving us. So let me go to the calculator and see what half of that is. So 2.75 divided by 2, that's going to be 1.375. So I want pi times 1.375 squared times this height of 60. And let me go back to the calculator and put that in. So let me see here. We've got pi roughly 3.14, although these graphers do have a pi button you can use. And then we've got 1.375 squared. Whoops, let me put a 7 in there. And another parentheses, there we go. And let's see, I think I mixed these up. See, calculator entry issues. All right, now we've got 60 over here. And enter. Comes out to roughly 356. So that's in cubic inches if you were curious, and that's going to be choice B. For this problem, we've got a trapezoid and a couple of measurements on here. We've got 10 inches on this side and 12 inches here and 60 degrees right there. And they didn't write the numbers, but we have 2 right angles here, which will also be important later on. Based on all this, we want the length of side TU, this long side on the bottom here. So in order to figure that out, it would help if we could get the 2 pieces of TU, this little piece with the triangle and this other piece with this shape here, and just add them together. Let's work on the triangle first. Since we've got 60 degrees here, and this is 90 over here, that means this is a 30, 60, 90 triangle, which has the ratio of sides S, S radical 3, and 2S. And that is on your reference sheet, I believe. So I'm going to go ahead and label each side of this triangle with one of these. So this is our 30-degree angle. So across from that, this is the S side right here. Across from 60, we have the S radical 3 side, which we're not going to end up using in this problem, but just for reference, it's there. And then 2S is going to be our hypotenuse here. Now, since the 2S side happens to be 10 inches, I can write 2S equals 10, which allows me to solve for S by dividing by 2, so I have S equals 5. Which means that this base of the triangle that I really needed turns out to be 5 inches. Now that leaves this other little piece here that I need in order to get this whole UT side. So it turns out this quadrilateral is a rectangle. We've got 2 right angles here. We also have parallel sides, which we know because it's a trapezoid. They told us that. So we're guaranteed that this 12 side here and this base side are also going to be the same because it's a rectangle. So we have 12 there. So then to get TU, we just do 5 plus 12, which gives us 17. Choice A. For number 31, we have a student making a deposit of 1,100 into a savings account and no additional deposits. So this is our balance after T years. So based on this, we want to know what about the savings account is not true. So 3 of these will be true, 1 will be false. First off, they're saying the account is increasing in value. Well, to figure that out with these types of functions, this is in the general format of p times b to the t or a times b to the t. It's an exponential function, and in these situations, this b value, which is 1.012 in this case, that's our growth factor. If that growth factor is larger than 1, that means it's actually growing. If this is a b value between 0 and 1, then it would be decaying. So fortunately, in this savings account, the account is increasing in value. That would be kind of a sad savings account if you were losing money each time. So because this b value of 1.012 is greater than 1, we can say that this is a true statement. We are growing. And we just said this was an exponential function, so if we're increasing, we are increasing exponentially. Next up, the account has an interest rate of 12%. So to get the rate from this growth factor, you essentially have to subtract 1 and then multiply by 100. So 0.012, if we multiply that by 100, move the decimal over 2, that's going to be 1.2% for the interest rate, which is close except for that decimal. This is actually a much lower interest rate than they're suggesting here. 12 would be phenomenal, but this is a false statement. And just to make sure we didn't leave anything out, account had an initial balance of 1,100. That is going to be this p value or a value, whatever you're calling it, out front here. So that is a true statement. Okay. So then, based on all this, we can say that C is the only one that's false. For this next problem, 32, it actually takes up a lot of space, but we're going to find these go pretty quickly. Part A here, so we've got this diagram with all these sides and angles, and triangle PQR, which is congruent to JKL, is not shown. We want the measure of angle R. Well, how could we possibly figure this out? So the way that these are written, the order of the letters tells us which angles are congruent with which other angles. For example, since R is in the third position after P and Q, that means that the congruent angle is going to be angle L, because L is also in the third position the way these are written. So if R and L have the same measure, if they're congruent, and L right here in the diagram is 28 degrees, that means R must also be 28 degrees. For this problem, we have another triangle here, XYZ being shown, and if you look closely, you'll notice that it has all the same measurements essentially as this first triangle. So based on the diagrams, they want us to write a congruence statement linking these two together. The key here is just to write the congruent angles in the same order for both of the triangles. So let's figure out what goes with what. Since I have JKL consistently in all my answer choices, I'm going to ask here which one is J congruent with. Since J is 30 degrees and Y is 30 degrees, we can say J and Y are congruent. Next, K is 122, just like angle Z, so those are congruent. And finally, L and X are both 28, so those are congruent. So then I can say JKL is congruent following the same order to YZX. And YZX, that's choice D. For number 33, we're being asked to consider angle S. Okay, I've considered it. And then they did a little construction using a compass and straight edge, and they showed what they did in this diagram here. So if you want to work through all these various steps, the basic idea is they set their compass here and used that at some angle to draw points T and R. Then they stuck their compass at T and R and drew a couple more arcs that crossed over at this point P. Finally, they took a ruler and drew a line from, or a ray I should say, from S through P. Now they're just asking what do these steps illustrate? How to do what to angle S so that which angle is congruent to which angle. So even if you've never actually performed a construction before, you can kind of intuitively see that if we have a choice between Copying, these are our two choices they gave us. Copying angle S or bisecting angle S, it looks like we are bisecting angle S. It looks like we're cutting it in half. So I'm going to write bisect. And then if we're bisecting it, which angles are going to be congruent? Well, it's going to be angle, let's see here, what are they calling this angle? I guess this is RSP is going to be congruent to TSP. So RSP congruent to TSP, that's these two angles. So this is the choice we'll pick from our drop-down menu here. And that's it. For number 34, this is a multi-step problem involving some systems of equations. In our first part here, we have Greta exercising for 2 hours each day. She runs R hours and then walks for W hours. They just want us to create an equation with an R and a W in it that can represent the amount of time and hours that Greta exercises each day. So we can write in general that the number of hours running, R, plus the number of hours walking, W, all of that should add up to the 2 hours that Greta is exercising each day. So we'll write equals to. And we're assuming that she's not doing anything else for exercise. For part B, we're told that Greta runs at a rate of 6.4 miles per hour and walks at a rate of 4 miles per hour, which seems pretty fast. She covers a total distance of 9 miles while exercising. We want an equation with an R and a W that represents the total distance in miles that Greta covers while exercising. So kind of our general format is we want to say that the distance covered by running plus the distance covered by walking should all add up to 9. So we need to figure out a way of talking about the distance covered while running and walking separately. Now let's say I wanted to figure out how far Greta runs. I have the speed she's running at, 6.5 miles per hour, and if I multiply that by the number of hours spent running, which is R, that would tell me how far she actually went. So 6.5 R is my distance covered by running. Using the same kind of reasoning, the distance spent walking is going to be her speed walking, 4, times the amount of time spent walking, which we're representing again with W. So we can write plus 4W. And again, if I add up these two things that are distances, I should get that total distance of 9 that they said that she made it. So there's our equation, 6.5R plus 4W equals 9. For part C, they want to know the number of hours Greta runs while exercising, and show or explain how we got this. So in order to figure this out, let me recall the two equations we've written. We have the equation about how long Greta is walking, R plus W equals 2, and then we had the equation we made about how far she walked, 6.5R plus 4W equals 9. We can solve this system of equations to figure out the amount of time, R, that Greta is running. We could also figure out how long she's walking, but they didn't ask for that specifically, so we're going to focus on solving for R. So there's lots of ways of solving a system of equations. We've got substitution, elimination, and a whole bunch of others that you probably haven't covered involving matrices. For this particular one, I'm going to go with elimination. Substitution could work just fine if I get one of these variables on this left equation by itself, but I kind of like elimination in these situations. So I want to do an elimination that is going to let me solve for R. So I'm going to do an elimination that lets me cancel out the W's, leaving only R's in a single equation. If I want to get rid of these W's, I need something that's going to cancel out this 4W. If I get this W on the left side to be a negative 4W, that would do the job if I were to then add the equations together. So I'm going to multiply this whole first equation by negative 4, and that's going to give me negative 4R minus 4W equals negative 8. And I'll just add these equations together. So these W's cancel out. That was why I picked negative 4 for that first equation. And 6.5R plus negative 4R is going to be 2.5R. And then 9 plus negative 8 equals 1. Now I just have to divide both sides by 2.5 to get R. And 1 divided by 2.5, what's that going to be? Well, you could do it on the calculator if you want. So on the calculator, 1 divided by 2.5 equals 0.4. So that is 0.4 hours that Greta is running for. For part D of this problem, we have Evan walking 8 miles per hour, or running rather 8 miles per hour, walking 3 miles per hour, and he wants to go 9 miles in no more than 1.5 hours. We want the greatest number of hours Evan can walk and still achieve this goal. So let's start by setting up a couple of equations to describe the situation. So we want his time running and walking, which we'll just call R and W, to add up to 1.5. So let's write R plus W equals 1.5. Next, just like we did with Greta, we're going to set up an equation talking about the distance as well. So the distance that he gets from running, that's going to be 8 times R, plus the distance from walking, which is going to be 3 times W. That should all add up to 9. So 8R plus 3W equals 9. And now we're just going to go ahead and solve for W. Now if I do this, I'll find the number of walking hours that gives me exactly 1.5 hours for the total time. And doing this is going to tell me the greatest number of hours that Evan can walk and still achieve his goal. So whatever this number comes out to, I mean, if he walks more than that, he's going to take more than 1.5 hours. If he walks less than that, he's going to take less than 1.5 hours because he's going to get there faster with the running. So by doing this, we're ensuring that we actually do get the greatest number of hours walking. So to solve for W, I want to get rid of R. I'm going to solve this by elimination again. And to get rid of R, I'm going to multiply this first equation by -8. Doing that gives me a -8R, which will cancel out with this R up here. And then we also have -8W. And let's see, -8 times 1.5, I think that's -12. Okay, adding these equations together, that cancels out my R's. 3 plus -8W is -5W. And then 9 plus -12 is -3. Dividing both sides by -5, 3 over 5, I believe that's 0.6. So that's the number of hours that, the most number of hours that Evan can walk if he still wants to go 9 miles in 1.5 hours. For this next multiple part problem, we have Jordan driving a car. Navigation system is giving directions to get to Jordan's destination, and says that Jordan should turn left onto Main Street in 1,000 feet. We want to know what's the closest distance in miles that we have to drive before turning left on Main Street. So basically they're just asking us to convert 1,000 feet into miles. Well, to do that we need a conversion factor. So we have 1,000 feet, and we know that 1 mile, and this is actually on your reference sheet, you could look this up on the test provided reference sheet, 1 mile is equivalent to 5,280 feet. So I'm going to multiply this by 1 mile over 5,280, because if I do that, these feet units will cancel out. And now I've just got 1,000 over 5,280. Now they wanted to know what was the closest to that. So although you could do it on the calculator, you could just reduce this. This is close to 1,000 over 5,000, which would reduce to 1/5. So 1/5 of a mile, and there's an answer choice for that, choice A. For part B, we're told that once Jordan gets to Main Street, it'll take 13 minutes to drive the remaining 5.2 miles to the destination. We want the average rate in miles per hour of that remaining 5.2 miles. So basically the speed Jordan has to drive at to get that far in that amount of time. So in general, we know that the average rate, the speed, is going to be the distance divided by the time. In this case, we have a distance of 5.2 miles, and we have a time of 13 minutes. Now, this is a little bit tricky because minutes, so the speed that they're asking for is in miles per hour. If we divide 5.2 by the 13, that's going to give us miles per minute, which we're then going to have to convert. So to save us kind of the trouble of doing that, I'm going to turn this 13 minutes into miles, or rather into hours. And to do that, I'm just going to take 13 and divide it by 60. I'm going to do that right in this fraction here. So I'm going to be doing 5.2 divided by 13 over 60, because 13 minutes is 13/60ths of an hour. And this is a calculator part of the test, so I'm just going to let my calculator do all that work for me. So here I am on the calculator. Let's do 5.2 divided by, let's see here, I'm going to need a parentheses for this. So 13 and then divided in there by 60, close parentheses, and that all comes out to exactly 24. Nice. So that's 24 miles per hour to go that distance in that time. For 36, we have a research company doing a survey asking people their age and whether they sleep later on Saturdays or Sundays. We want to know, based on the table, what fraction of people surveyed who are ages 35 to 50 sleep later on Sundays. Okay, so let's look here. We've got ages 20 to 34, 30 to 35 to 50, Saturdays, Sundays, and totals everywhere. So 35 to 50, sleeping later on Sundays, that's this 93 right here. So that'll be our numerator. The question is, what should the denominator be? So the way they've worded the question, they're saying what fraction of people surveyed who are ages 35 to 50. So we're kind of assuming that we're only looking at the 35 to 50-year-olds. How many of them are there? The total, given over in this column, is 120. So 120 then is going to be our denominator, 93 out of 120. And that is going to be answer choice C. Now just to explore this a little bit, in case you're still kind of skeptical, the only other answer choice with the 93, by the way, in the numerator was choice D, and that would have been out of 155. This would have been asking the question, what fraction of people who sleep later on Sundays are of the age 35 to 50? I know it sounds kind of the same, but it is a little bit different. We're taking as our starting point only the people who sleep later on Sundays, and then we'd be asking about the age. And if the 240 was the denominator, we'd be asking what fraction of people surveyed are 35 to 50 and sleep later on Sundays. So the wording is very important on these. For number 37, they're giving us two circles, F and G, on this coordinate plane. And they are saying to prove the circles are similar, translate circle F such that its center is the point, and then we have to figure out the new point, and then dilate it by a scale factor of, well, we got to figure out that too. So where would I have to translate the center of F to in order to prove that it's similar to G? Well, if I could translate the center of F over to the center of G, that would be a good start. G is at the point 1, 0. So that's what I'm going to put in here, 1, 0. Now, if I've got this circle shifted over here, to prove these are similar, I need to expand this circle until it looks like circle G. Circle G is 3 times the radius of circle F. So I'd want to multiply all the dimensions of circle F by 3. So scale factor of 3 would do the job for that. For 38, we have Terry with a bag o' marbles, 7 reds and 8 blues, and they're all the same size and shape, and Terry randomly selects a marble from the bag, does not return it to the bag, that's very important, and then randomly selects another marble. We want the probability that the first marble is red and the second marble is blue. So in probability fancy terms, we're asking for P of red, probability of red, followed by the probability of blue given that a red marble has already been drawn. So probability of blue given red. So the probability of a red marble, there are 7 red marbles, there are 15 marbles total, so 7 out of 15 gives us that first red. Next up, the probability of a blue marble. Since we haven't drawn a blue marble yet, there's still 8 of those available to draw, so that's our numerator. But now how many marbles are left for the denominator? Since you already got one of the red marbles, that leaves 6 red marbles, so that's a total of 14 marbles left overall. So that's 8 over 14. So the good news is we don't actually have to multiply that and simplify it. We just have to find this in the answer choices, and it looks like that's right here with choice D. For this multi-part problem, we have a ball thrown from the top of a building as an experiment, and the graph down here is showing the height in feet of the ball 8 seconds after it was thrown. So horizontally we've got time, and then vertically the y values, those are all heights. First part is they want the coordinates of the point on the graph at which the ball reached its maximum height. Well, the maximum height is right here, that's the top of the graph, and they just want that point, which is just going to be 2, 140. So that's choice B. For part B of this problem, they're giving us a series of 3 true-false statements that we have to unravel. So let's take these one at a time. First one, the ball was in the air for a total of 6 seconds. Well, in the air means we have a height that's greater than 0. The ball hits a height of 0 down here at 5 seconds. So that is a false statement. The ball was only in the air for 5 seconds. Next, the ball was thrown from an initial height of 80 feet. So that's asking at time 0, how high was the ball? Well, time 0, that's the left side of the graph here, and we see that it is indeed at 80 feet. So that must be the how tall the top of the building was. So that one's true. And finally, the height of the ball was increasing for a greater interval of time than it was decreasing. Well, we're asking basically how long was the ball going up versus how long was it going down. The ball is going up for the first 2 seconds until we get to that spot we found in part A. And then we're decreasing our height for the next 3 seconds until we hit the ground. And they were saying the ball was increasing more than it was decreasing, but that's not true. It was decreasing more than increasing. So this is a false statement as well. For number 40, we have a line intersecting this triangle at points N and point Q, and we've shown all the measurements in here that they've given us. So 28 centimeters for this piece of the triangle, 12 centimeters for this piece. There is actually a few that they didn't show us. They said the length of MP, that's this whole side of this triangle, is 44 centimeters. And they're also telling us these two lines are parallel. So this 44 centimeters piece, if this whole side of the triangle is 44, that means this little piece here, which might be helpful, is 44 minus 28, or 16 centimeters. Now what do they actually want to know? They want the length of PQ. So because these lines are parallel, that means that this triangle, this little triangle up here, and the big triangle down here are proportional, they're similar. It also means that these 4 pieces, the 16, the 28, the missing piece, and the 12, are in a proportion as well. So if we just set up a proportion, we can solve for this side, which I'm going to label this with an X just so I have something to refer to it with. So let me set up an equation. I'm going to say 28 over 16 is equal to X over 12. That is my proportion. I've got top over bottom equals top over bottom. These sides should be in the same ratio to each other. And now I just have to solve this for X. I'm going to cross multiply in a moment, but let me just reduce this 28 over 16 first to 7 over 4. That's going to make it a little bit easier to solve for X. Now if I cross multiply, I've got 4 times X on one side, 7 times 12, which is 84 on the other. And then dividing both sides by 4, I get X equals 21, which gives me answer choice C. For number 41, we have a city planner recording the number of residents in each apartment building in a city and each building's distance from the city center. And this is modeled by this P equals 510 minus 17D equation, which is kind of interesting. This is saying the number of people in a building equals 510 minus 17 times the number of miles from the city center. So because this is a negative 17 times d, basically as d increases, as you get farther from the city center, the number of people in apartment buildings is going down, which makes sense. The further away you get from the center of the city, the more spread out your population is going to become. So they want us to complete a couple statements here about this. Based on the model, the number of residents of an apartment building, and I think that the choices were increases, decreases, or stays the same or something, and by how much for every 1 mile increase in the distance from the center. So again, this is negative 17, so it's definitely decreasing, going down. And every mile you go from the center, you're increasing d by 1, so you're subtracting another 17 for every mile you go. This is a linear function. So we're going to say decreases by 17 for every 1 mile distance, increase in the distance from the city center. So we finally made it to question 42, the last question on the calculator part of the 2024 MCAS. We've got points E and G lying on a circle F. They didn't show it, but I'm going to draw it. So here's circle F, and we've got E and G on there. There's E, there's G, okay. And we have the radius of circle F being 15 centimeters and the length of arc EG being 12 pi centimeters. They want the measure of angle EFG. So let me draw that angle. F again is the center. So I have a radius going from E to F and from G to F. So here's EFG. They told us the radius was 15, so there's that. And this arc they said was 12 pi. Let me label that as well. And I want this angle. So let me put an X there just to show what I'm actually looking for. All right, so how do I find this? Well, we're looking for an angle. The angle here is proportional to this arc length versus the circumference of the circle. So we're actually going to set up a ratio. This angle is the same fraction out of 360 degrees that this 12 pi is out of whatever the circumference is. So I'm going to set up a proportion showing that. Before I can do that, though, I need to figure out the circumference of the whole circle. So let me do C equals 2 pi r. That's our circumference formula. So we have 2 pi times the radius of 15, which we can just write as 30 pi. No need to turn it into a crazy decimal just yet. And now let me set up a ratio. I can say that 12 pi, my arc length, over 30 pi, my circumference, is the same ratio equals x, the central angle, divided by 360. Now before I cross multiply, let me reduce this left fraction just a little bit. 12, so the pi's cancel totally. 12 over 30 is really, let's see, reducing by 6s, that's 2/5. So we have 2/5 equals x over 360. Cross multiplying now, we have 5 times x equals 2 times 360, which is 720. And what is 720 divided by 5x? Since this is the calculator part of the MCAS, let me just plug that in my calculator. So 720 divided by 5 gives me 144. So 144 degrees, which is choice B.